Hello, welcome to this session recording from the AWS Summit London 2015, focusing on an introduction to Amazon EC2. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services based in Europe. I'm going to be joined later in this session by Richard Ainley, a member of our AWS Solutions Architecture team from here in the UK. Before we get started with the content in this session, I'd just like to let you know that if you'd like to download the slides from this session, please take a look at the video description on YouTube for this video. You'll find a link there to the AWS SlideShare where you can view and download the slides from this session. Of course, if you want to stay up to date with Richard or I, you can find us on Twitter using the details that you can see on this first slide. So in this session, we're going to be talking about EC2, the Amazon Elastic Compute Cloud. It's a service that actually has a lot of depth, many different features, and actually a lot of different benefits as well. That's really going to be the focus of this introductory session today. Some of the things we're going to cover include the EC2 user experience, the purchase options that you have for acquiring EC2 computing resources for your applications or workloads. We'll talk a little bit about different kinds of virtual machines that you can use. Then we'll spend a little bit of time talking about networking and other performance factors as well. But before we get started on that, what is Amazon EC2? Well, that's very simple to answer. You probably know the answer to this already. It's elastic virtual servers running inside the AWS cloud. What exactly does that mean? Well, AWS takes care of the heavy lifting from constructing and operating the data centers to putting all the equipment in those data centers that you need to connect and access your virtual machines, installing the host servers, of course, operating and managing the hypervisor, which is Zen based incidentally, and then providing you with a virtual machine with the dimensions that you specify in terms of the amount of CPU, memory, RAM and IO capability that machine has. And then you just make use of it to install your application or other workload upon, and off you go, you're running. So essentially what we're doing is abstracting away a lot of the complexity of operating your own compute resources, and of course offering a different financial model for access to those resources as well, which we'll cover in more detail later in this session today. So in summary, EC2, the Elastic Compute Cloud, it's a service that makes it easy for you to access elastic server capacity. You've got choice of instance in terms of CPU, memory, storage dimensions that you might want to use. You have several different deployment options. It makes use of these Amazon machine images. We call those AMIs, sometimes armies, which you'll hear more about in the session today. That's the base image from which you kind of rehydrate or create your machine at creation time. And from there you can customize and, of course, install your own application software on that machine, on that EC2 instance. EC2 is a service that's actually been around for quite a while. It's one of the first services that Amazon Web Services launched back in 2006. That was when the beta started for EC2. And over the course of that period, it's a service that's evolved a lot. You may not know this, but when we launched, we only had a single instance family and a single size. It was Linux only. And many of the common features that are used with EC2 today were not features of the service at launch. And this meant the applicability of EC2 in its early days to more traditional kind of enterprise IT use cases or use cases that focused on established apps. It was more limited than it is today, significantly more limited than it is today. Today you can use EC2 to run pretty much any application or workload that you want, but that hasn't always been the case. And since the launch of the beta in 2006 and subsequent GA, we've added a lot of new features to the service. Things like new instance families and sizes, support for Windows, of course, and enterprise Linux, different purchasing models like RIs, reserved instances, or the spot market for spot instances. We've added the GUI, the AWS Management Console. That was not there at launch, believe it or not. Neither was the Elastic Block Store. So there was no independent persistent storage with EC2 instances when the service was first launched. You only had instance storage, which we'll talk about later. And that instance storage would be reset, essentially, non-persistent storage. So it would be erased each time you stopped and started your instances. So your persistence had to be handled in a different way using S3 at launch. We now have EBS, which of course addresses that issue. We've added EIPs, elastic IP addresses, the virtual private cloud, VPC, auto-scaling, elastic load balancing, many performance, security, manageability and scalability improvements. And most recently, we've added the EC2 container service, or ECS, which is a highly scalable, high-performance container management service that allows you to run Docker containers on EC2 instances, enabling you to manage distributed applications on a managed cluster of EC2 container instances. And we've got another session in the recordings from the London Summit which talks about this service, EC2 Container Service, or ECS, in much more detail. The other thing, of course, that we've done over that interceding period, over that last 8 to 9 years, is we've seen a lot of adoption of EC2 around the world amongst a broad range of different customers, from public sector with government, obviously, through to very, very large numbers of commercial entities that are making use of this service. We now operate in 11 regions around the world with 28 availability zones, and complement that with 53 edge locations for CloudFront and our DNS service, Route 53. And importantly, the availability zone construct, it very much applies to EC2. So each region has multiple isolated availability zones, and you can make use of EC2 within those availability zones to place your instances and data in multiple locations, multiple physical data centers within the same region. So you can build applications on EC2 that have really very, very good performance and availability characteristics as a result of that, if you use the architectural guidelines that we provide to you. So do bear in mind that you've got access to these distributed data centers, these different availability zones that you can make use of in each region where we provide EC2 today. And this growth continues. You may have seen this statistic before, but every day AWS adds enough new server capacity to support all of Amazon's global infrastructure when it was a $7 billion enterprise. So continues to be a service which is growing extremely fast. And one of the reasons for that is we have a broad selection of instance types today that allows you to satisfy the resource needs for a diverse range of different workloads. And what we do here is we essentially optimizing around particular resource types, with the exception of the general purpose and micro instances, which are balanced and provide balanced amounts of CPU and memory. The other families that you can see here are optimized around more provision of a specific resource. So obviously the compute optimized resources, instances rather, the latest being the C4, they offer higher proportions of CPU capacity. So if you want to run CPU constrained workloads, you're going to find the compute optimized family is the most cost efficient way to do that. They offer the best price per CPU cycle that's made available to you in those instances. Similarly, we're optimizing for memory with the R3 family, for storage density with the new D2 family, for I/O capability with the I2 family. And then we have a special instance family called the G2, which provides an NVIDIA Kepler floating point unit with very many parallel floating point cores in it, which are good for rendering or computational fluid dynamics or other floating point intensive workloads. I'm talking now about the latest generations when I talk about the C4, the R3 and the D2. And of course this slide shows you the prior generations. They're not available immediately through the website. The details aren't, but you can click back and see prior instance generations on the website, take a look at the specifications and pricing for those older variants of those various instance families as well, if you wish to do that. And the naming is important. So when you're looking at the name of an instance, the instance family is denoted by the first prefix, so the C for CPU, the R for RAM. The instance generation is the number, so the higher that is, the more recent the generation is. And then you have your instance size: small, medium, large, X large, 2XL, 4XL, 8XL. So you can tell at a glance what kind of instance you're running and roughly how big it is as well. Let's move on now and talk a little bit about performance factors. And when choosing an instance, obviously there's some critical factors that you want to consider to make sure that your workload gets the best performance and you're also cost optimized. And one of these is obviously the CPU that's made available to you within the specific instance family that you're using, the generation that you're using, and of course how many CPUs are available, which is determined by the instance size that you have. And in the C3, R3 and I2, we have the Intel Xeon E5 268 V2 Ivy Bridge CPUs. So 2.8 gigahertz base performance level in the C3, which can be turbo enabled to 3.6. And this CPU supports AVX enhanced vector instructions. So if your compiler supports that, you can take advantage of those for your workload. And then in the latest generation, in the C4, we have an even newer Intel Haswell. This is the E5-2666 V3 Haswell. And this is a special CPU that's been developed in conjunction with Intel specifically for AWS, offering higher clock speeds, so 2.9 gigahertz in the C4 with turbo enabled up to 3.5 gigahertz. And this supports the AVX2 enhanced vector extensions, as well as supporting some other features such as crypto extensions as well. So if you need more details on that, you can find those on the product detail page if you look at the C4 instance family. And of course, once again, if your compiler supports those extensions, you can take advantage of the performance benefits that those will provide. Another important performance factor is networking. And it's worth saying here that network performance for EC2 instances scales with instance size. So the larger your instance, the more network performance you will be able to drive through it. This is at its peak, really, when you're looking at the 8XL instance sizes, where we provide something called placement groups. It means these instances can be placed adjacent to each other on the same 10 gigabit network interconnect, providing full bisection 10 gigabit networking bandwidth between instances in a placement group with no network oversubscription, which offers very, very high network performance, as you can probably appreciate. And we offer an additional software feature called Enhanced Networking, which is available on the instance families that you can see there. Basically, the newer instance families, D2, C3, C4, R3, and I2, provide this. You have to be in a VPC and you have to be running an army that has HVM support. And this Enhanced Networking will offer up to 1 million packets per second throughput, as well as reduced instance-to-instance latency and more consistent performance. So it's pretty obvious that if you're running a workload that has demanding network requirements, you want to be making use of Enhanced Networking. There are limitations, as I've said. You need the HVM virtualization type to be the virtualization type for your machine image. You have to be in a VPC, and there are some kernel and driver requirements that you can see on this slide as well. But this is a really good fit for workloads like one of my personal favorites would be like first-person shooters, where you need to drive really high throughput with low latency and consistent performance. If you run those game engines on a instance family, a C3 or C4 instance family, a larger size one, and use enhanced networking, you'll get excellent network performance, which is more than adequate for running those near real-time application types. The final performance factor that we're going to look at is storage. And there are several different options available to you here. The always around or classic instance storage that's locally attached inside the physical servers that actually host the instances themselves. You can access storage there in many of the different instance families that we provide. Now, it doesn't persist on instance termination, so it's not necessarily good for all use cases, but it is high performance and you don't have any I/O charges associated with instance storage, so it definitely has its uses. Then we have three different types of EBS, the Elastic Block Store, general purpose SSD-backed volumes, provisioned IOPS that allow you to dial in the level of I/O you need, and they provide consistent performance for I/O intensive workloads such as databases. And then EBS magnetic volumes. These are backed by rotational magnetic drives, traditional hard disks if you like. They're ideal for workloads where data is accessed less frequently and where lowest cost is important. So you want to cost optimize your block storage usage. You can use EBS magnetic volumes for that. If you want to learn more about EBS performance, there's a session recording from the AWS Summit in London from my solutions architecture colleague Tom Maddox, where he talks about optimizing EBS performance with EC2. So if you want to dive deep on that, check out that session recording. And then finally, integration with Amazon S3 and Amazon Glacier. So this is our high-performance durable object store in the case of S3 and our low-cost archive storage in the case of Amazon Glacier. These services are located in the same regions as EC2 and offer very, very high-performance interconnect between S3 and EC2, so you can quickly and very, very responsively access objects that you might have stored in S3, and you control access to those objects using IAM roles and instance profiles, which enables you to provide a security framework around S3 for specific instances to access specific buckets or prefixes in a controlled way. So there's strong and tight integration between those different services, and would recommend that customers make use of S3 where it's appropriate, take advantage of the durability and performance characteristics coupled with the security that it offers. The T2 is an interesting instance family worth talking about in its own right for a couple of reasons. First of all, it offers burstable performance, so you can accrue CPU credits with the T2 instance family, where if you're not using all of the potential CPU performance that's available for you, CPU credits will be retained for you in a credit bucket essentially. If your workload has bursty performance and requires a period of higher performance, it can drain that bucket and the CPU can burst using those performance credits that have been accrued over time. Turns out that a significant number of workloads fit this profile really well, including most web applications. So it's an excellent instance type to use for front ends in large-scale web apps. And then the T2 Micro is the instance which is offered under the Amazon EC2 free tier. And this allows you, for the first year after creating your AWS account, to access 750 hours a month of an Amazon EC2 T2 Micro instance running Linux, and the same for a T2 Micro instance running Windows. So you have a significant amount of free EC2 usage available for you for the first year of your AWS account's lifecycle. And this doesn't necessarily have to be one instance running for the whole month. You could run 24 instances for 1 hour a day, accrue the same number of hours, and experiment with scale-out architectures on AWS at no cost to you during that first year of your account's lifecycle. So check out the free tier if you're interested in that, awsamazon.com/free. So why do customers use Amazon EC2? Let's take a look at a couple of examples of customers that are using EC2 today to help them operate their applications and scale their businesses on the AWS cloud. The first organization that we're going to take a look at is AdRoll. Now, AdRoll are a global leader in retargeting, and this is the technology that enables advertisers to follow you across the web. If you've ever wondered how, when you say visit a website where you might be looking at cars, say you're on Audi.com looking at cars, the next minute you jump onto another website to do your food shopping, and in the side panel is an advert for an Audi trying to tempt you back to complete the transaction that you were performing on the prior website you were on. If you've ever wondered how that happens, well, the answer is that service, that technology is delivered by organizations like AdRoll. They are a very large provider of this service with over 10,000 active advertisers in more than 100 countries around the world. And performance is super critical for this kind of workload. They need to take a decision about precisely which advertisers' content they're going to show to you in under 100 milliseconds for each placement opportunity that they have. And also they have highly variable demand across the day. They have way more people needing to make retargeting decisions during peak hours, say in the US, when the US peak time zone is late in the afternoon or in the evening, for example. Many more people using the web and using mobile devices than there are at 4 in the morning. And AdRoll want to optimize performance and cost across that time series, essentially, to make sure they've got enough capacity when they need it, but they're not paying more than they have to when they don't. And they make very extensive use of AWS to achieve this, and EC2 is a core component of their system, enabling them to balance cost and performance. And you can see this quote here from CTO and AWS community hero, Valentino. Secondly, Condé Nast. So this is a more traditional workload, a publisher that wanted to transform the way in which they operated their IT infrastructure. They decided to migrate their data center to the AWS cloud. They moved over 500 servers, a petabyte of storage, and many mission critical applications, including core business apps like HR, legal, and sales, as well as 100 database servers to AWS. And they've migrated to a large fleet of EC2 instances now, rather than running their own on-premises data center. And there's a pretty cool video actually I think it's on the AWS YouTube channel, where they're showing precisely what they did with their data center after they'd concluded this migration. It ends with a for sale sign going up outside their facility as they remove the last of their equipment from their own premises and operate completely inside the AWS cloud today, relying extensively on EC2 to enable them to do that. Okay, so that's a couple of examples of customers that are using Amazon EC2 today. I'm going to hand over to Richard Ainley now. I'm going to talk to you about some of the benefits of using AWS and Amazon EC2 to host your workloads and applications. Over to you, Richard.
Thanks, Ian. So why do these customers and many others, from startups to enterprises to government institutions, find EC2 attractive? Well, they can scale as required. They can run any application in the hardware configuration and operating system they desire. They can improve resiliency, they can run applications securely, and they can reduce costs, both operating costs and capital expenditure. First, elasticity. For us in the cloud, it's the ability to add and remove instances to work on the application's demand. Elasticity helps you save money, it helps handle cyclical and unexpected demands, so you don't have to guess capacity. It improves availability, it helps maintain application response times, and it can help maintain fleet utilization rates. Here's a chart of server load versus time, where you can see a gradual spike in activity midday. Fictitious graph, but common for many applications. It's busy during the day when people are awake, and it's quiet at night. I've added a new line here showing the capacity of one EC2 server. That would cover you till 8 AM and then later on after 4 PM. But if we stuck here, we'd have some unhappy customers above that line. So 2 servers would usually be bought in advance, covering the full demand curve. In reality, you want a standby for failure or unexpected peaks also, but let's run with the model we've got. So the area underneath the curve is the capacity needed and the expense of that capacity. And the area over the curve under the top line is the savings potential. Even coarsely, being able to provision what you need when you need it, you save a third of the traditional capacity requirement. And it's easy with EC2, you just purchase on demand and pay by the hour. And if you have a peak, you can react to that as well and have a better customer experience. As you're provisioning by the hour, you could be more granular and get a closer fit to the demand curve, saving more and getting rid of the orange area above the server load. It's important to leave a safety margin. You don't want to wait to scale when the CPUs are at 99%, so you will have a little bit of orange around the outside, but it's good to leave that safety margin. Some apps are spikier. For example, you might have an enterprise app that is used for forecasting runs throughout the year. Towards the end of the month, you see a spike of load as users log on to forecast for the next month. So the end of the month needs a substantial uplift in instance numbers. In this example, the end of the month need is predictably about 6 times what is required during the remainder of the month. The expense to provision for this peak is significantly higher than it was in the previous example. Therefore, the savings opportunity is higher as the difference between the top line and demand is larger. Again, we provision EC2 to meet the capacity. With this predictable workload pattern, you can really capitalize on the savings opportunity with EC2. In this case, it's 75%. So scaling can be automatic, it doesn't have to be manual, and we have services that can add servers automatically to a group to support the increased load. The CloudWatch, for example, is our monitoring service, and that will help you check the CPU or RAM across your fleet amongst other metrics, so that you can trigger auto-scaling based on one of those metrics. So for example, you might monitor CPU across your fleet, and if CPU levels across the fleet raise above 80%, you might decide to add another EC2 instance. And on the flip side of that, if the CPU level drops below 60%, you might decide to remove an instance, so saving you money. And then on the right-hand side, we've got the Elastic Load Balancer, the ELB, and this will help you spread the load that's incoming across those servers. So the next reason customers like EC2 is that you are in control of your EC2 instances. There's no tickets to raise, they are your instances. You can start and stop them via the console or the API. You have root in the case of Linux or administrator logins in the case of Windows. You can install what you need, you can make configuration changes you like. And you can wrap all that up in an Amazon machine image in Army and relaunch it when you need it. We have two other services to give you further control over your AWS resources. For example, you might want to control who can stop and start your instances. And you can do that with Identity and Access Management, IAM, and that will help you control who can do what. And then you can use CloudTrail as your audit record, and that will enable you to record who did what. Screenshots again showing that you have full access, root or administrator to these instances. Customers also like the flexibility to run any application on the hardware configuration and operating system they desire. The flexibility to choose which operating system, for example Linux or Windows, the AMI required from the community, or maybe a marketplace or ISV partner. For example, we've got WordPress powered by Bitnami, or security platforms from partners like Sophos. You can choose your instance type, so the CPU, RAM or disk combination, and you can vertically scale that when needed. You just need to stop your instance, change the instance type and start it again. You can add storage required in terms of volume and performance, and you've got the flexibility to change that as well. In a lot of AWS case studies, customers talk about improving reliability. So how do they do that? We talked before about the ability to auto-scale your applications with an increase in server load. The use of Amazon EC2 with auto-scaling and elastic load balancing are an example of an architecture that can be used with multiple availability zones to create a highly available application. Let's look at ELB, auto-scaling groups and availability zones coming together to help reliability. So this is a standard 3-tier web application architecture. This is a very powerful pattern that shows you how EC2 with multi-AZ can allow you to build highly reliable applications. So static content is delivered through CloudFront, our content delivery network. The elastic load balancer does health checks. If the elastic load balancing finds an unhealthy instance, it stops sending traffic to the instance and reroutes the traffic to healthy instances. At the same time, autoscaling periodically performs health checks on instances. When autoscaling determines that an instance is unhealthy, it terminates that instance and launches a new one. Using this functionality across multiple availability zones allows your architecture to fail over to either availability zone, enabling a highly available web architecture within a region. At the back end, we can see our relational database service, RDS. This is a managed database service, and it supports a number of flavors of database, for example, Oracle, SQL Server, MySQL, Postgres, Aurora. Amazon Aurora is a MySQL compatible relational database that combines the speed and availability of high-end commercial databases with the simplicity and cost effectiveness of an open source database. You spin up an RDS instance and we hand you an endpoint. You can specify that you'd like a multi-AZ instance. And what that is a second instance in another availability zone that's synchronously replicated. And we can synchronously replicate because of the proximity of the availability zones to each other within a region. So it's close enough for a single-digit millisecond latency, but far enough apart to have a different risk profile. If the master fails, we direct the database traffic to the multi-AZ instance, and there's no action from you required. Back to Ian.
Thanks, Richard. So the last things I'm going to cover are security, different purchasing models, and how you can get started with EC2. So we'll cover security first of all. And the first thing to say, of course, is that EC2 fits within the security framework that AWS provides for all of the services that we offer. Okay, so you're going to take advantage with EC2 of the foundational security that's inherent within the AWS Global Infrastructure. Things like secured and anonymous premises, secured access and separation of roles, built-in firewalls in the form of security groups, the fact that you can uniquely define and control who can do what within your AWS account using AWS Identity and Access Management, or IAM. You can integrate that with multi-factor authentication. You can make use of private subnets within the AWS Virtual Private Cloud or VPC service. You can encrypt your data storage using the new key management service or your own key management. And of course, you can make direct connections from AWS regions to your own premises or your own network using AWS Direct Connect, enabling you to establish part of the AWS cloud, which is not connected to the internet. It's purely connected to your own network to enable you to host and operate applications there, or even extend the capacity of an existing data center into the AWS cloud. And these security practices and principles have been verified by a wide range of different third parties, from the Motion Picture Association of America through to the payment card industry, through to the ISO 27001 standard for information security management, and a host of others as well, which you can see on the slide. So if you're operating in a regulated industry, please take a look at aws.amazon.com/compliance for more information about our compliance with these standards. One of the most important services to enable you to assure the security of your EC2 resources is, of course, the Amazon Virtual Private Cloud, or VPC. And this is now the default. So if you have a new AWS account and you create an Amazon EC2 instance, by default it will be placed inside your default VPC. And VPC allows you to provision a logically isolated section of the AWS cloud. So you can connect this back to your own on-premises network using either Direct Connect or a hardware VPN, another service that we provide as part of the VPC. And it enables you to control your networking environment. So you can use constructs such as your own subnetting layout, control over your own route tables, implementation of security groups, which are per instance firewalls that you can use to allow traffic. And the default is to deny, but you can use to allow traffic on certain ports to reach your instances or flow from your instances, and network ACLs, which you can apply to subnets to add further deny rules. And these construct, when considered in its entirety, and enables you to control if and how your instances access the internet. So it's a very, very powerful service, which I'd encourage everyone that's making use of Amazon Web Services to learn more about. And you can find more details at aws.amazon.com/VPC. Finally, cost effectiveness, and we did touch upon this at the very top of the session today, but there are several different purchasing options for Amazon EC2. The longest established, and I guess most well known still, is on demand, where you simply pay for compute capacity by the hour with no long-term commitments. It's good for spiky workloads or in the early stages of running a workload where you're unsure what the demand level or usage profile is going to be. If you wish to optimize your costs further, you have the reserved instance and spot instance opportunities that you can take advantage of. Now, with reserved instances, you're making an EC2 usage commitment for a period of 1 or 3 years, and you're going to receive a significant discount in return for that usage commitment. And we'll talk more about those discounts in a second. But this is excellent for committed utilization, where you know you're going to be running an application for a certain period of time. You maybe need a certain number of instances for a period of time, or you know that your baseline load on your application is going to be at a certain level around the clock, or for a certain percentage of the day, and then you can buy that baseline load as reserved instances, allowing you to blend that with on-demand and or spot, and that'll reduce your costs. The spot market, this enables you to bid for unused capacity charged at a spot price, which fluctuates on the basis of supply and demand. That's updated every minute. This is good for time-insensitive or transient workloads, or for things like cost optimizing batch operations, where you may run a large analytics job periodically. If you assess the cost of instances from the spot market at that time, if they're lower cost than on demand, you can inject some spot instances into your workload to reduce its duration and lower its cost. The spot's used very frequently with analytical processing and high performance computing workloads for that reason. And then lastly, dedicated, slightly more expensive than on demand, but it enables you to launch instances within a VPC that run on hardware dedicated solely to you for highly sensitive or compliance related workloads where this might be a requirement. You can ensure that all of your EC2 instances are running on hardware that is dedicated to you alone, and you can use the dedicated purchasing model for that. Just to add a little bit more detail on the reserved instances, because this is a very common and highly recommended optimization technique. If you use the no upfront option, where you still pay hourly, but you're committed to pay hourly over the period of your reservation, 1 or 3 years, you can achieve up to 55% savings by doing that. If you do partial upfront, where you make a prepayment and then pay a reduced amount hourly, that will generate up to 76% discount in comparison to that no upfront option. And with the all upfront option, you can achieve a 77% discount in comparison to on demand. That's where you prepay for all of your usage over the term of your reservation. So if you do want to know more about those, maybe discuss how you might be able to optimize your costs for EC2, then do give us a shout via the Contact Us form on the AWS website, or contact your AWS account manager or SA if one's been assigned to you, and they will be able to help you, or we will be able to help you work through how using reserved instances may help you optimize your cost of operation on Amazon EC2. You find more alternative options for purchasing reserved instances in the Reserved Instance Marketplace, which is a secondary market for RIs that customers have bought but wish to resell. There's one caveat here, which is that you can only engage in this marketplace as a seller if you have a US bank account. But customers that might be watching this session recording here in Europe can still engage in this marketplace as a buyer without having to fulfill that requirement. And you can find here short duration and discounted RIs that have been sold by customers that no longer require them. So you can buy things on a shorter term or buy instances at a lower cost if you check out the RI marketplace. It's a screenshot of the spot market, which shows spot pricing, spot instance pricing history. And you can see at the top here that the spot market is broken down by product, by instance type, and then shown by availability zone in specific regions. And if you're looking for spot instances that you want to use for those batch orientated workloads, maybe for large scale analytics workloads, you can use third-party tools to bid in the spot market. Some of which are open source, like our own CFN cluster. Our HPC control framework is integrated with spot market purchasing, or you can acquire spot instances directly from the EC2 console. So check out those options for making use of spot for your workloads. Last thing we're going to look at is how to get started with Amazon EC2. And the first thing to say is it's extremely simple now via the console to launch instances. So if you jump onto your console, click the EC2 service icon, and you'll have a wizard-based guide that takes you through the process of launching an instance there. You'll also find that the AWS Marketplace is integrated directly in the console, so you can browse thousands of AMIs, armies, directly from within the Amazon EC2 console and find either an Amazon, a community contributed, or a third-party commercial army that meets your use case directly from within the console now. The marketplace is an online store that enables you to buy software directly from within the marketplace, which is integrated in the console. As I've said, you've got this one-click launch process that allows you to run products in minutes, and there are over 2,000 products there listed today, so it's gone up a little bit since this slide was produced even. And there are a lot of benefits from using the marketplace, really. You can find and deploy software quickly. Whatever software you use will be billed via your AWS account, so you will not have to negotiate terms or set up payments with other third parties. You've got a very, very simple purchasing model. So I'd really like to encourage you to investigate the AWS Marketplace if you've not already done so at awsamazon.com/marketplace. So next steps you should take after watching this session, please either sign up for an AWS account if you don't already have one. Take advantage of the free tier and applicability of the free tier to those T2 micro instances, enabling you to familiarize yourself with Amazon EC2 without having to spend anything for the first year if you're using T2 micros and under 750 instance hours per month. And of course you can learn a load more actually about Amazon EC2 from the product detail page at aws.amazon.com/EC2. So that concludes this session. I'd like to thank you for joining us for this session recording from the AWS Summit in London 2015. As usual, we really appreciate you giving up your time to learn a little bit more about AWS. And if you want to stay up to date with us, you can find AWS on Twitter at AWS Cloud, and you can stay up to date with the latest news from AWS here in the UK and Ireland at AWS_UKI, also on Twitter. And lastly, if you want to continue to learn more about AWS, you might also be interested in webinars that we're running throughout 2015. You can find more details on those if you take a look at the links in the video description for this video on YouTube. And a reminder also that you can download the slides from this session. Once again, if you check out the links in the video description, follow the SlideShare link, you'll find all the presentations from the AWS Summit in London 2015 available for download in PDF right there. Thanks again for joining us. I hope to see you again on a webinar or some other AWS content very soon. Bye-bye.